Okay, now we have finished the first chapter and moving into the another chapter. So here, mechanics. This is not the name of the chapter actually. So this is a branch in physics which deals about the motion of the bodies. This is a study of the motion of the bodies, a branch in physics which is the study of the motion of the bodies. And this mechanics is again having the two branches, that is statics and dynamics. And the statics deals with the bodies at rest. The bodies at rest. And this dynamics deals with the bodies in motion. The bodies in motion. So this is a branch in physics which talks about the motion of the bodies, and this mechanics and the two branches here. One is the statics, other was dynamics. And again this dynamics is divided into two categories, that is kinematics and another one is dynamics. Actually, to say kinematics is a part in the dynamics. And here the difference between these two is, here we talk about the motion of the bodies, and here also we talk about the motion of bodies, and here without considering the cause, without considering the cause, the responsible thing, what is necessary for the motion, we don't consider that. For example, here, suppose if a body is said to be in motion, to keep the body in the motion, what do we require? What I'm using here? The force. Or else if we have to use some energy to drive some machines, we don't consider all those things here. We just look at the motion of the bodies, that's all, and we do not consider the cause. And dynamics, by considering the cause. By considering the cause. And here we go with the kinematics. And again in these kinematics, first we start with, so here kinematics means we are going to talk about the motion. We are going to talk about the motion. And here the motion, if you look into the motion here, like the motion in a straight line, motion in a plane, and motion in a space, like that we can categorize. So we just take, we consider taking the motion here. So it is motion in a straight line, a straight line, and this is the second one is motion in a plane. Wait, I will explain you. Plane, purely plane. And the other one is motion in space. So like this we can categorize the motion here. So here motion in a straight line means, suppose if you take an example, the car moving in a straight road, that means particularly in a single direction. If it is moving in a straight path, then we will be calling the motion in a straight line. So, and we will be calling this motion in a straight line as motion in one dimension. Motion in one dimension. Okay. So, motion in a straight line, we can call it as the motion in one dimension. Just to show this motion in one dimension, so if you want to show where the body is, for example, just I will make it here. Suppose if it is starting from here, point A, and the body is moving to B and then to C. So let this be 5 centimeter, and let this be from here to here, it is from another 5 centimeters. So like this it is moving. So to represent it by using the coordinates, so what we do is we take this x-axis and y-axis. So no need to represent this by using two coordinate axes. One is enough. Either you can go with the x-axis or you can go with the y-axis. That means you look here, just look here. The body is moving in a straight line. So from point A, the body has moved for 5 centimeter. From point A, the body has moved for 5 plus 5, 10 centimeter. Okay. So that means from this point here, suppose if it is, let us take here, consider here. So initially it is 0. So it is 0 here. So let me take it here. So now it is moving for 5 centimeter. And it is moving for another 5 centimeter. So like this. So here only one coordinate is enough to just represent this. So one coordinate. In your mathematics you might understand about the coordinates as x coordinate, y coordinate. X coordinate means distance moving along x-axis, considering the x-axis. So that is one coordinate. Either you can take it as the x or y or z, the three coordinates, the three axes here. And so this will be calling as motion in one dimension. And coming to the motion in a plane. So how to understand this motion in a plane? So let us take this wall. So now I want to, or just I will make a diagram here. This is, let us think this is a wall, and now a point is here. If I ask you where the point is, how can you say the point is here? That means you cannot show it with the finger and say that the point is here. By just showing with a specific magnitude or with the direction or something, by something we have to say or express where the point is. The way how we can go or express where the point lying is. So look here. So how easily we can go with it. So let us think this is a plane. This is a plane, and now I am taking this as the x-axis and this as the y-axis. So from the origin, this is the origin. So at what distance it is on x-axis? That means here. So the 1, 2, 3. So if this is given in the meters, so it is at 3 meter on x-axis. 3 meter on x-axis. So I will represent 3. So if we just leave it as 3 itself, it means that from origin the body is from 3 meter only. So we cannot say the point is lying in the space. So not in the plane. Is not lying in the plane. So from x it is at 3 meter. So this is your 3 meter, and from y, from the origin on y, so it is 1, 2, 3, 4. It is 4, 3, 4. So by looking at this, now if I ask you where the point is lying in the plane, you can say it as it is 3, 4. If you say it is 3, 4, other person can easily understand that, oh, it is from 3 meter from origin on x-axis, 4 meter from origin on y-axis. I'll just go with one more example here. If I say the point is lying in a plane, and where the point is means it is, if I say it is from 6, 7, what do you understand that? So it is in a plane, and it is at 6 meter from x-axis and 7 meter on y-axis. So here your point is lying. So like that you can understand the point lying in a plane. So if you are just dealing with such type of things, we will be calling the motion in a plane, and this will be naming it as motion in 2 dimensions. So here to represent this, one coordinate is enough. To represent this, 2 coordinates are necessary. And coming to the motion in space, suppose if I On the plane means I have taken the wall here, or a board or something else, or white paper, whatever it is, it's a plane. If you want to take another example as the space, suppose if the point is somewhere here, here it is here. Now if I ask you where the point is, so here you have to take some reference point to show where the point is. So now what are the reference points? Look here. So if this is a room, this corner, the lower corner, this side, is one reference point, and this side, the lower corner, is another reference point, and this corner is another reference point. So here, three reference lines we are taking here. One is in this, like this, another one is like this, another one is like this. So one is this corner, another one is that corner, other one is this corner here. And you already know about this. This is represented by X, Y, or Z. Usually we go like this. This is generally taken as X, this is generally taken as Y, this is generally taken as Z. It is not necessary that always it should be taken as X. You can take it as Y, or you can take it as Z, you can take it as X. But the condition is these three should be mutually perpendicular to each other. That means one should be perpendicular to the other. So now, I have taken the example here, no? So where the point is, here the point is. So from this axis from origin, this corner is taken as the from three where these three corners are meeting. I am taking this as the origin. This as the origin. From the origin, so on x-axis, where the point is lying. So on the x-axis, where the point is lying. So here the point is lying in the space. From the origin, from up on x-axis, where the point is lying. 1, 2, 3, 4. 4. So the first coordinate represents the distance on x-axis. The first coordinate represents the distance on x-axis. Then this alone is not sufficient to just give the complete sense. And from this corner, so now the point is here. From the origin on y-axis, at what distance the point is lying? From the origin on this axis where the point is lying. So here the point is lying. So 1, 2, 3, 4, 5. And your second coordinate is 5. Similarly, here we cannot, on the paper we cannot show how much it is on z-axis, but in the space, because the paper is plane. Okay, so now in the space here we have to show for this third axis also. So from the origin on z-axis, at what distance the point is lying? So 1, 2, 3, 4, 5, 6, 7, 8. So now the third point is 8. Look at these coordinates here. Here only one coordinate is enough in the case of this motion in one dimension or motion in a straight line. For motion in a plane, two coordinates are necessary, and to represent the point in a space we require the three coordinates. One is on x-axis, one is on y-axis, one is on z-axis. And this we will be calling as motion in space as motion in 3 dimension. Okay, so like this we will be talking about the motion, and first we will talk about the motion in 1 dimension, that is motion in a straight line. Okay, now just pause the video and take the screenshot. Okay, now we are in motion in 1 dimension. Okay, so now first let us understand the basic things in this motion in 1 dimension. Already basically you might have learned all these things in your 9th class, isn't it? Hope so. Okay, anyhow, we'll just go for a repetition once again. First we should talk about rest and motion. When the body is said to be at rest, the body is said to be at rest if it is not changing its position, with respect to surroundings. With respect to surroundings, that we will be calling as the rest. If it is not changing its position with respect to surroundings, then we will be calling as the rest. And the motion, when we will be calling this as the motion, if it is changing its position with respect to surroundings, we will be calling that as the motion. Okay, and the important thing is rest and motion are relative. They are not absolute, but they are relative. They are not absolute, but they are relative. Right. What does this mean? I think you might have heard this particular sentence when you were in 9th class, isn't it? What does that mean? Rest and motion relative. I'll make you to understand with an example. For example, if you are traveling in a bus, and if you just observe the driver, with respect to you, the driver is in rest. Is he really in rest? No. With respect to a person who is standing outside the bus, and the bus is moving, some other person who is standing outside the bus, what he feel is, so the persons in the bus and with including you are in motion. So with respect to one body, the body is at rest, and with respect to another body, the body is in motion. So this shows that rest and motion are relative. They are not absolute. That means they are not independent or as by their own. Rest and motion are relative. So like this we have to understand, and just keep this in your mind. Okay, right. Now next is distance. This term you might be hearing about this term right from your 6th class maths, learning from the beginning of your mathematics, isn't it? So anyways, here we have to define this and understand this once again. It is the total length covered by the body. Total length covered by the body. While it is in the motion here, the total length of the path covered by the body. And the important thing is here, no need to specify the direction. Okay. So that means here, suppose if a body is starting from here and it is reaching B. Secondly, we have to here take into consideration where this body is moving. That means we have to consider the path, complete path. We have to measure the entire path length, and that gives you the distance. And if you just look into once observe the path here, just if you consider this point. At this point, what is the direction of the body? This is the direction of the body. At this point, what is the direction of the body? This is the direction of the body. At this point, what is the direction of the body? This is the direction of the body. So no need to bother or worry about the direction when you are talking about the distance. That means it is a scalar quantity. A scalar quantity. And as you know, the units for this is, you see, nothing but distance is nothing but the length. So what are the units of length? It is meter, centimeter. This meter is in SI or MKS, and centimeter in CGS. And here already told you, whenever we come across any physical quantity, we should talk about the dimensions. What are the dimensions? Dimensions of length is L1. These are the dimensions of the distance. I'm coming to the very next term to it. What is the very next term to the distance? Displacement. Displacement. Let us take the same example here. Can we take this complete path as the displacement? No. Then what is the displacement? It is a straight line path from initial point to the final point. Means here, suppose if a body is starting from A and if it is moving to B, when you are talking about the displacement, you should not consider wherever the body is moving. Just you have to consider the initial position and the final position. Just consider this enough. No need to bother or worry where the body is roaming and where it is moving. Nothing to worry. So from initial to final. And a straight line path. Draw a straight line between them. So if we just draw a straight line path, this shows that the body is moving in a particular direction. Or in a specific direction. Okay, so this is the only direction here. So the body is moving in a particular direction, specific direction. That means here, when you are talking about the displacement, you are considering the direction. So when you are talking about the displacement, it's a physical quantity. To represent a physical quantity, we need magnitude. And here, alone magnitude cannot give the complete sense for the displacement. We have to specify its direction, in which direction it is moving. Okay, so just to define this, we understood that here the straight line path from initial position to final position, a straight line path. If you want, you can answer in a particular direction also, you can specify that, no problem. And here, we understood that this has a particular direction, so this is a vector quantity. This is a vector quantity. And the units for the displacement, it is also length, isn't it? If I say this is the displacement, this you have to measure. Your measuring means it is the length. So displacement is also the length. The units are SI, in MKS it is meter, and CGS it is centimeter. And here also we should talk about the dimension, and the dimensions are L1. So that's about this displacement. And let us take some examples and understand about this distance and displacement. So now, suppose if it's a ground, and from here you are throwing a stone. So now the stone has gone up to this height, h, and you know that again the stone will come down. That means again it comes to the same and it travels the same distance, isn't it? H. If I ask you what is the distance, distance is h plus h, that is 2h. And what is the displacement? Displacement is, and here just I'll tell you one thing, distance is denoted by d and the displacement is denoted by s, and if you want you can keep a bar on it showing that it is a vector quantity. Okay, now so if you want you can keep the bar, or else no problem. So distance is h plus h 2h. What is the displacement? Displacement means you have to consider the initial position, final position. That's all. So this is your initial position and that is your final position. The initial position and final position are coinciding. That means this is your initial position, that is the final position. What is the distance between them? 0. So the length between them is 0. So it is 0. So from this example we are understanding that distance is there and even then the displacement is 0. Okay. And one more thing we can say, if the can the distance be 0? Can this be 0? When we will be saying the body is having some distance, if it moves, so this cannot take the 0 value, but the displacement can take the 0 value. Okay. So now, by this example, we understood that displacement is 0 and displacement is distance. When distance is having some value, displacement can be 0. And we can go with one more example here, with the body moving in a circular path. If the body is moving in a circular path, what is the distance covered for one revolution? So from here the body is starting and it is moving along the circumference of the circle. How to find the circumference of the circle? Using the formula 2 pi r. So what is the distance here? The circumference. So what is the formula? 2 pi r. If r is the radius. So distance is this. What is the displacement? So this is the starting point and that is the ending point. Initial point is that and final point is also the same. Both are coinciding. That means the length between them is 0. So displacement is 0. This is one more example. Isn't it? You can go with one more example here. If you are starting from your home, coming to school, and again by evening you reach home, what is the distance covered by you? Distance covered by you is from your home to school, some maybe 5 kilometers, and from school to home another 5 kilometers. 5 plus 5, 10 kilometers. Distance is 10 kilometers. What is the displacement? The initial point is your home and the final point is your home. Both are coinciding. So now what is the displacement made by you? 0. Okay. So even though distance is having some value, displacement can take 0 value. Okay, right. Now let's go with one more example here. Suppose a tower is there and from here you are throwing a stone. So it reached to certain height and just fallen down. Okay. Let us take the tower of the body is height h. Sorry, the height of the tower is h. And let us think that it has reached the height x. So now, what is the distance made by the body? Distance covered by the body. So from here to here it is x. So x. From again here to here it is another x. And from here to here it is h. So it is 2x plus h is the distance. Now what is the displacement? It is not reaching the same height. It is not stopping here. It is coming back or going down. So here, in which direction you are throwing the body? You are throwing the body in this direction. That means this is the direction what you are throwing. This is the direction. This is the direction the body you have thrown. Now the body finally reached in the opposite direction. That means here how to just show it means here. So here from here to here it is x and x. So actually up to here it is 0. The displacement by the body up to here is 0. But it is traveling in the opposite direction by height h. Traveling in the opposite direction by height h. Now actually the magnitude of this is h. But it is moving in the opposite direction, so minus h. The magnitude of the displacement is h. But we have to make others understand or yourself understand or to make everybody understand that it is moved in the opposite direction, make it as minus. So here the displacement is minus. So from this example we understood that the displacement can take a negative value also. So displacement can be 0, displacement can be negative, displacement can be positive. But distance, if no distance is covered, it can take 0 and positive value, but distance cannot take negative value. Okay, so these are some examples for understanding the distance and displacement, and we'll just go with the next section. Now take a screenshot of this.